I'm going to discuss some few properties of determinants, very important properties. Properties of determinants. The first property is, there are 6 properties, okay, very important properties which we'll be utilizing while expanding determinants. The first property is, suppose there is a given determinant, the value of the given determinant remains unchanged, okay, even if a row and a column of that determinant is interchanged. Ekta determinant is row ekta. In a given determinant, you exchange the row and column. Suppose you exchanged R1 and C1. Okay. So, in a given determinant, even though you exchange a row and a column, then the value of the determinant still remains unchanged. Is it okay? So the value of the determinant remains unchanged even if a row and a column are interchanged. Are you following that? Now? So let me give an example. Suppose your determinant, your given determinant is 1, 2, 3, 1, minus 4, 6, and 2, 1, 4. Just say this is your given determinant. Or I can take it in general form. You can take it as A1, B1, C1, A2, B2, C2, A3, B3, C3. You can take it in general form. Or you can just take an example. I'll take an example. Let me take an example of a 2 cross. Let me take an example of a determinant of order 2. 1, 2, minus 1 and let me take the positive values 1, 2, 3 and 4. So this is a determinant. Let me expand this determinant. 1 times 4 is 4 minus 3 times 2 is 6. 4 minus 6 minus 2. Now to this determinant you can interchange a row and a column. Suppose I interchange R1 and C1. So to this given determinant 1, 2, 3, 4, we can exchange row 1 and column 1. Suppose row 1 becomes column 1 and column 1 becomes row 1. Then your determinant will now become 1, 3, 2 and 4. Is it okay? Now we expand this determinant. 1 times 4 is 4. Minus 2 times 3 is 6. The value still remains the same. Is it okay? So the value of the determinant remains unchanged even though a row and a column of the determinant are interchanged. Row or column interchange korilebi determinant laga value to kodai same thakibole lagi. Is that clear to you? Okay, that is the first property. So the value of the determinant remains unchanged even if, okay, its rows and columns are interchanged. That is the first property. Second property is, if any 2 rows or any 2 columns are interchanged. If any 2 rows or any 2 columns. The first one was interchanging row and column. But this time you are going to interchange between the rows. Or you will interchange between the columns. So if any 2 rows or any 2 columns of a determinant are interchanged, then we always write a negative of the given determinant. Is it okay? The given determinant to negative ho jayenge. Interchanging 2 rows will give a negative, will give minus sign to the given determinant. Interchanging any two columns will produce a negative sign on that given determinant. Are you getting me? Let me take an example. Suppose your determinant is 1, 2, 3, 3, 2, 1, minus 1, 1, 2. Is it okay? So this is your given determinant. I'm going to interchange any two rows here. Suppose row 1 goes to row 2 and row 2 goes to row 1. Then your determinant will become row 2 goes to row 1 and row 1 goes to row 2 while row 3 remains unaffected. So interchanging any two rows will produce a negative sign on the determinant. Or interchanging any two columns will give a negative sign on the determinant. Is it okay? Again, suppose you want to interchange row 1 or row 3 with row 2 now. You want to interchange row 3 with row 2. Suppose you want to interchange row 2 and row 3. You interchange them. Okay, there is a negative sign here. Now interchanging any two rows will give you another negative sign. Right? Then you have 3, 2, 1. Minus 1, 1, 2, 1, 2, 3. So this minus minus becomes plus, right? And 3, 2, 1. Minus 1, 1, 2, 1, 2, 3. And so on we can continue on. Is it okay? Interchanging any two rows or any two columns produces a negative sign on the determinant. There is the second property. You're not supposed to forget any of the properties, okay? The third property is if any two rows or any two columns are identical. If any two rows and or any two columns are identical, then the value of the determinant becomes 0. Two rows are identical means all the elements of that two rows, the corresponding elements of those two rows should be equal. Two identical columns means all the corresponding elements of those two columns must be equal. Identical, okay? So if any two rows or any two columns of a determinant are identical, in that case your determinant becomes 0. Example, your determinant is 1, 2, 3. This is your third property, right? 1, 2, 3, 1, 1, 1, and 1, 2, 3 again. Here in this determinant, we see that the first row, your row 1, and the third row, row 3. Are they identical? All the corresponding elements are equal. In that case, your determinant is 0. Alright? Or if any two columns are also identical, then your determinant will be equal to 0. Are you following that? Okay. So that's the third property. The fourth property is if any row or any column is expressed as a sum of two terms. If any row or any column is expressed or is given as the sum of two terms, then the given determinant can be represented as the sum of two determinants. If any two rows or any two columns, has been expressed as the sum of or the difference of two terms, then the given determinant can be expressed as the difference of two determinants. I'll give you an example. Suppose your given determinant is 1, 2, x plus y, 1, 4, x plus y, 3, 2, oh no, this is x plus y plus z, z plus x. Here we see that the third column has been expressed as the sum of two terms. So your given determinant will also be expressed as the sum of two determinants. So how do I write? 1, 2, x, 1, 4, y, 3, 2, z, plus 1, 2, y, 1, 4, z, 3, 2, x. So this is your delta 1 plus 2. Are you following me?
Okay.
For difference also it's same. It can be sum of 3 terms. It can be sum of 4 terms. If any row or any column has been expressed as the sum of 3 terms, then your determinant should also be expressed as the sum of 3 determinants. Maybe 4, maybe 5. Is it okay? Yes. So that is the 4th property. The 5th property, if you are to multiply any row or any column by a scalar, then whole of the determinant has to be multiplied by that scalar. Multiply a row by a scalar, then the whole of the determinant has to be multiplied by a scalar. Is it okay? Suppose your determinant is 1, 2, 3, and then this example is very obvious. This is very obvious property, so no example is required here. Very obvious property. Okay, so this is just very obvious, so no example is required. So multiplying any row or any column by a scalar, your determinant also gets multiplied by that scalar. Is it okay? Yes, any scalar. The 6th property is, even though you do any row operations or any column operations, okay, we studied in matrices. On finding the inverse of a matrix, you did different kinds of row operations. Also, you could be able to do any kind of column operations, right?
Yeah.
So even though any row operations or any column operations has been performed on a determinant, the value of the determinant always remains unchanged.
Like row equal column equal row equal.
Amigo, suppose your given determinant is 1, 2, 3, 3, 2, 1, 1, 2, 1. Suppose this is your determinant. On expanding this determinant, expanding along R1, on expanding this determinant, you got the result to be 14. I don't know, it's maybe incorrect. 14 will never be the answer. Okay, it's incorrect. But suppose I'm assuming that the expansion of this determinant gives you 14. Now what I'm going to do is, see, I feel that expanding this determinant will consume more time. So I'm going to do some operation here. I'll try to make more zeros on this determinant. Then what I'm going to do is, row 3 or R1, row 1 goes for row 1 minus row 3. To row 3 you subtract row 1. No, to row 1 you are subtracting row 3. Then your determinant becomes 1 minus 1, 0. 2 minus 2, 0. 3 minus 1, 2. And then 3, 2, 1, 1, 2, 1. I have done some row operation here, and then I expand the determinant. Then the value of the determinant remains unchanged. Which is enough? So, yeah.
Already property number 3. Identical rows are column 3.
Yeah.
So in this determinant it's like 1, 2, 3, 3 to 1. So row 1.
No. Identical means all the corresponding elements must be equal. Here it is 1, here it is 3. Corresponding elements are not equal. Okay, identical means all the corresponding elements should be equal. Alright? Yes. Yeah, you can clear your doubts in that way. That's good. So see, after doing some operation here, we obtained the value of the determinant to be 14. In this case also it is 14. Okay, just an example. Okay. So doing any kind of operation on the rows or columns, the value of the determinant always remains unchanged. So those are the 6 important properties of determinant, and using these properties, using these simple concepts, we are going to solve exercise 4.2. Okay, 4.2. So let's start with exercise 4.2. The first question. All you have to do is, sometimes it will be very confusing, this exercise, but knowing all the properties, okay, things becomes very easy.
Sir,
Yeah.
like matrices in determinants also, applying the operations will be same, right? Row
Yeah,
means
yeah.
everything will be row.
No. You can apply row transformations, column transformations also.
Oh, in between.
Yeah, in between, yes.
Okay, one
Yeah, alternate, you can do it alternatively.
Okay.
You cannot do row operation and column operation at a time,
Okay.
but it can be done alternatively. Okay? Yeah, it's no problem. So using the property of determinants and without expanding. No expansion should be done. Okay? From 1 to 7. Using the property of determinants only and without expanding in exercise 1 to 7. In 1 to 7 we are not supposed to expand. Okay? And using the properties only we are going to solve. So number 1, you have to prove that your determinant x a x plus a, y b y plus b, z c z plus c, z plus c, z plus c. We can say that z plus c. Okay. Now we need to prove this, so we take the left hand side. Your given determinant is x a x plus a, y b y plus b. Look at the pattern: x a x plus a, y b y plus b. Sounds like music.
Yeah.
Z c z plus c. Now see, I can use a very important property here. All the properties are important. The third column has it been expressed? Is it been expressed as the sum of two terms? Yes. So the given determinant can be expressed as the sum of two determinants now. Now this is equal to x, y, z, a, b, c, x, y, z, plus determinants will be expressed as the sum of two determinants, right? X, y, z, a, b, c, and a, b, c. Now you see, in this determinant, do we have two identical columns? So if a determinant has two identical columns, then the determinant will be 0. Here also we have two identical columns, C1 and C2 are identical. All the corresponding elements are equal. So this determinant will be 0. So the overall result is 0. So this determinant, without expansion, we get the value as 0 using the properties. So which is equal to your right hand side. Are you following that? I'll try another one. Number 3. We want to show that 2, 7, 65, 3, 8, 75, 5, 9, 86 is equal to 0. Here we can use logical sense. You see, 65, I'm going to break 65, okay, 65 into two parts as the sum of two numbers. It may contain 7 or 2. You can break 75 as, okay, into two terms, such that one of the term contains 8 or 3. Now, and I'm going to split this 86 into two numbers, make 86 as the sum of two numbers. Either one of the number can be 9 or 5. In that case, two columns can be identical. Now, so on the left hand side, we have 2, 7, 65, 3, 8, 75, 5, 9, 86. What I'm going to do, I'm going to break up 65. 2, 3, 5, 7, 8, 9. 65, can I write 2 plus 63? Now, 75, I can write 3 plus 72. 86, I can write 5 plus 81. So that two columns will be identical. Now your third column, has been expressed as the sum of two terms. So the given determinant will be expressed as the sum of two determinants, right? 2, 3, 5, 7, 8, 9, 2, 3, 5 again, plus 2, 3, 5, 7, 8, 9, 63, 72, 81. Here on the first determinant, two columns are identical. So your determinant will be 0 here. Plus, now we will use the property. Here, see, in the third column, all the elements of third column is a multiple of 9. So I can take 9 common. Okay, and I can write 2, 3, 5, 7, 8, 9. 9 7 times is 63, 9 8 times is 72, 9 times is 81. Right?
Yeah.
So in this case, two columns are identical, C2 and C3. So 0 plus 9 times 0. So your given determinant is. Are you following that?
Okay.
That's a very simple property. So using the properties, we can simply do it. Okay, from 1 to 7. So you can try the remaining ones.
Up to 7 now?
Yeah, up to 7. But it's not necessary you do it all. Suppose number 6 is very easy.
Yeah.
So you can practice at home. So you can try from 1 to 4. 2 and 4, since I have done 1 and 3, so you can go for 2 and 4.